We start with next set of questions. 10 more questions I discussed today in this video of our second CET class. Here we read the next question, 13th one. I ended in the 12th question there in the last video. Now I am taking 13th. We read, a simple pendulum has a length L and the mass of the bob is M. The bob is given a charge Q coulomb. The pendulum is suspended between the vertical plates of the charged capacitor. If E is the electric field distance between the plates, the time period of the pendulum. Observe the pendulum time period. If it is a normal pendulum, normal simple pendulum, it depends on the acceleration due to gravity. But when we apply an electric field like this, say this is positive plate of the capacitor, this is negative plate, and there is the simple pendulum. At any point, it is acted by two forces, mg downwards and either this way or that way the electrostatic force E into Q, where Q is charge on the bob. Therefore, there are two forces acting. At any moment, it has two accelerations, one parallel to the field, one perpendicular due to the acceleration due to gravity. Therefore, there is a net acceleration at some direction. That net acceleration can be written as A equals root of acceleration due to electric force square plus acceleration due to gravity square. But we know E electric force equals EQ by M. Therefore, net acceleration is root of EQ by M whole square plus G square. Therefore, in the period formula, T equals 2 pi root of L by G. In place of G, we have to substitute A. Therefore, new period T dash is 2 pi root of L by A. According to that, option 2 is correct because A is root of Q by M whole square plus G square. So, option 2 is right. Now, going over to the next question. Say electric intensity due to an electric dipole varies with R as E proportional to R to the power of N, where N is. You all know for the electric dipole, the field is always inversely proportional to cube of its distance from the dipole, either on end-on portion or on, say, broadside-on portion, that is on axial line or on broadside equatorial line. Now, from the given formula, this can be written as R to the power of minus 3, which implies N is equal to minus 3. Therefore, option 2 is correct. Now, going for 15th. 2 point charges are 3 meters apart. Their combined charge is 8 microcoulomb. That means I can write simply Q1 plus Q2, two charges whose sum is 8 micro. Now, the force of repulsion between them is 0.012 Newton. Charges are, that means I can write force F as from Coulomb's law, say 9 into 10 raised to 9 Q1 Q2 by distance square 3 square. So this 3 square cancels here and this is given to be 0.012 equals 10 raised to 9 Q1 Q2. Therefore, I can simply write it as 12 10 raised to minus 3 equals 10 raised to 9 Q1 Q2. So, the product Q1 Q2 will be now 12 into 10 raised to minus 12. Observing Q1 plus Q2, 8 microcoulomb. Observing Q1 Q2, 12 into 10 raised to minus 12. So, among the given 4 options, for any option, sum to be 8 and product to be 12. That is the correct option. Say here in the first option, 4 plus 4 will give us the sum 8, but 4 into 4 is not 12. Therefore, first option is not correct. Second option, say 6 plus 2 is 8, right? And 6 into 2 is 12. Therefore, option 2 is right. Option 2 is correct. Now we go for 16th question now. We read, a charge Q situated at certain distance from a short electric dipole in the end-on portion experiences a force F. End-on means on the axial line. That is an old name used usually in magnetism to say on the axial line. Therefore, end-on means axial line. Force is F. If the distance of the charge is doubled, from the dipole is doubled, force acting on. Just now we said in one of the previous things, electric field due to dipole is inversely proportional to cube. Therefore, force is also inversely proportional to cube of the distance. Therefore, as R dash is 2R, the distance is doubled, the new force should be proportional to 1 by 2R whole cube, which amounts to be 1 by 8 R cube. Therefore, we can simply say F dash equals F by 8. The option 4 is right. Option 4 is right. So, now going over to 17th question. A distance between 2 point charges is increased by 20%. The force of interaction between the charges. Say, we know F according to Coulomb's law is inversely proportional to R square. Therefore, I write F initial as 1 by R1 square. And it is given distance is increased by 20%. Therefore, R2 I can write R1 plus 20% of R1 is written as 20 by 100 into R1, which amounts to be 1.2 R1. R2 is 1.2 R1. Therefore, after increasing the distance, F final will be proportional to 1 by 1.2 R1 whole square. That means F final is proportional to 1 by 1.44 R1 square. Therefore, the percentage change is equal to F final minus F initial divided by F initial into 100. Just observe, all other things except for 1 by 1.44 is are constant. Therefore, F final I can write simply 1 by 1.44 minus 1 into 100. All other things get cancelled. Therefore, we have, if we take this as say 1 by 1.44 approximately taken as 1.4 as 0.7 minus 1 into 100. So 0.3 into 100, which amounts to be 30% approximately. Therefore, answer is fourth option. The answer is fourth option, the 31%. That is question number 17. Now we go for 18th question. Like this. It's a very beautiful question to go for. It depends on law of equilibrium of forces. Now observe, we read, two small spheres of masses m1 and m2 are suspended by weightless insulating threads L1 and L2. The spheres carry charge q1 and q2 respectively. The spheres are suspended such that they are in the level with one another and the threads are inclined at vertical inclined to the vertical at the angles theta 1 and theta 2 as shown. Which one of the following conditions is essential if theta 1 equals theta 2? That means we do one thing. Say in this figure we write down the force acting on M1 and M2. First force M1 on M1 is M1G. On the other force is tension T1 I write. Other force is M1, say other force is F Coulomb, Fc. On the M2 also M2G and Coulomb force Fc and the tension T2. Now, as you all know, this angle is theta 2 and this angle is also theta 1 by alternate angles idea. Now, from the left hand side figure, I can write by resolving the vectors T1 cos theta 1, which is vertical component, which should be equal to M1G. And also for the same thing, I call this as equation 1. Fc, the Coulomb's force, is equal to T1 sin theta 1. I call this as equation 2. In the same manner, for right side part, I can write T2 cos theta 2 as M2G and Fc as T2 sin theta 2. This is our equation 3 and 4. Now, if I divide equation 1 by 2, equation 1 divided by equation 2 will result in T1 by T2 is M1 by M2 as theta 1 equals theta 2 given. And similarly, dividing equation 1 by 3 here and dividing equation 2 by 4, I get T1 by T2 as 1. Therefore, from these two, M1 equals M2. Therefore, that is the condition if theta 1 equals theta 2. Option 3 is right. Option 3 is right. So with this, we think of the 19th question. It's also a very easier one. In the uniform electric field given, an electron is accelerated from rest. The velocity of the electron when it has traveled a distance of 2 into 10 raised to minus 2 meters nearly. Observe, I write the formula. We have given distance, therefore velocity is required. I write v square equals u square plus 2as. But u is 0 as it is given at rest. A, I can write it as E by m. But we are given with E by m. Therefore, E into E by m is the acceleration. And S is also given 2 into 10 raised to minus 2 meter. Substituting all these things we get, and taking the square root, we get 2 into E by m into S is 2 into 10 raised to minus 2. We substitute everything now. 2 into E 10 raised to 4, E by m 1.10 raised to 11 into 2 10 raised to minus 2. Observe now, 2 will result in 2 square 4, which is taken as 2 outside. Now we left with 1.8 inside and also the power 11 plus 4 15 minus 2 10 raised to 13. What I can write as 2 into 18 into 10 raised to 12. So which gives me 2 into 10 raised to 6 root of 18. Observe, root of 18 is will not give us the whole number, but we can do that calculation or we can arrive at the answer by simple logic. Say root of 25 is 5, root of 4 is 16. Therefore, root of 18 is slightly more than 4. 4 into 2 is 8. That means answer somewhere be around 8. That is option number 3 is correct because it is 8.5 into 10 raised to 6 what we are getting there. Therefore, option 3 is correct. Now, going for the 20th question, we read. Two charges Q and minus 2Q are separated by distance D. If the electric intensity at the site of Q is E, then the electric field at the site of minus 2Q is. Say I write the diagram like this. Say first diagram is Q here, I call it as A. And then B at B minus 2Q is there and the distance is R. Now what I do, at the site of Q, if the electric intensity at the site of Q, that means I take only B, that is minus 2Q, and I write only electric field at A without charge Q, that is E, it is minus, so it should be attractive this way. This is EAB, electric field at A due to charge at B. I can write EAB, what is given as E, as K 2Q by R square. Now, that is our E. Then they are asking us to calculate what is the electric field intensity at the site of B. That is 2Q, minus 2Q. Now, I replace Q to its place A and I consider point B only without its charge. Now we write the electric field here. It is positive charge at A, so electric field is in this direction. I call it as EAB. According to, EBA, electric field at B due to charge at A. According to, say formula again, EBA can be written as K Q by R square. But comparing EBA with E, I can simply write it as E by 2. As EAB is, say, K2Q by R square, E by 2. Therefore, option 2 is correct as the distance are say directions are same. A to B is E, B afterwards is also EBA. Therefore, their directions are same. So, option 2 is correct. Option 2 is correct. E by 2. As they are the same direction, the sign is positive. Now, the 21st question will tell us about something about effective distance. We read, the electric force between the two point charges separated by distance D in air is F. Say, if I have Q1 here, Q2 here with separation D, the force is F in the air. What I can write is as F K Q1 Q2 by D square. Now, this, remember, this is capital K, the proportionality constant. Now, if we replace the gap between two charges by the medium of dielectric constant K, I write small k, lowercase k. If the dielectric constant K, now the force with the medium, this I write as force with air, this I write as force with medium. What I can write it as, say the same constant K, Q1, Q2 by dielectric constant K, D square. For the forces to be equal, F air to be equal to F medium, then From these two, we get, say, by cancelling all those things, or we substitute first, k q1 q2 by d square, k q1 q2 by small k d square, k d dash I take. This thickness as d dash I take, therefore k d dash square, now k d dash square. Therefore, all other things are same. Now I write d square equals k d dash square. So the distance to be between the charges in the dielectric medium is given by d dash equals d by root k. D by root k. Distance d dash equals d by root k. Therefore, fourth option is correct. This is also called as the effective distance. The final question for this session is like this. Two point charges Q1 minus 2 microcoulomb, Q2 minus 1 microcoulomb are placed as shown. It is given here. I write here minus 2 microcoulomb and minus 1 microcoulomb. The coordinates of the point P are 2 centimeter and 1 centimeter. That means the coordinates are 2, 1. That means this distance is 2 and this distance is 1. The electric intensity vector at P subtends an angle theta with the positive x-axis. Then the value of theta is given by, say if I mark this as theta, this is also theta. We write down the electric field intensity vectors due to two charges. First one, here is minus charge, here is to write, say electric field intensity, I write like this, I call it as EP1. And in the same manner, here minus charge, again electric field due to Q2 is to be written as EP2. Now, these two produce the resultant field along P to origin, PO. Now we are asked to calculate the tan theta. I write from the figure tan theta as opposite by hypotenuse. Opposite is EP2 by EP1. But we can substitute for EP2 and EP1. Kp2 means 1 microcoulomb, 1 micro by distance 1 square divided by EP1. EP1 is K 2 micro divided by distance is 2 square. Say, assuming the centimeter is converted into meter, all those things will cancel. Now I can write, say here 1, 2 goes, only 2 left there. Therefore, option 2 is correct. Tan theta is 2. Again, after solving these 10 questions here, I feel to get good marks in the CET, you require to practice a lot. Yesterday I have given you around 12 questions. Today I am now giving you 10 more questions. And I have solved them. Please try to solve them on your own without looking at the solutions once you go through this. And make yourself perfect. And also in the meanwhile, due to the lot of time what you have now, you just practice as many problems as you get in the other textbooks or other, say, reference books. Say goodbye for this session. We'll see in next session in the same chapter.